Okay, we want to talk about clustering. This isn't specifically for R. This is just in general about clustering. And so we're going to have a quick introduction, and we're going to talk about Kmeans clustering here, which we're going to use in our Chapter 7 text mining. So it's called unsupervised learning because when we're clustering, we don't have a class variable. I'm not sure if we discussed that or not, but anyway, okay, let's just go on. So what we have is we have a bunch of data, just like we have our data. For example, we have our movie data, and our movie data has, like we said, like 1,300 dimensions or variables. But here, this data has just 2 dimensions, so it's much simpler, of course, to try and show it if it's just 2 dimensions. So let's just say we just have 2 dimensions. Okay, and what we're looking for is we want the program, the computer algorithm, to figure out where, to see separate groups here. Now all it has is, it doesn't see anything, right? We see it, you see it, but it doesn't see. But all it has is a bunch of points of data, a bunch of x and y coordinates, like this dot will have a certain x coordinate and a certain y coordinate, and this dot will have a different x coordinate and y coordinate, and so on. So it just has a list of x and y coordinates. In other words, a list of the points, but as I said, it doesn't see anything like you can. Now you see this, and you probably can identify. Now we're ignoring the fact that there are squares and circles here. So just suppose they're all the same. But still, you can probably, I think most of us would say, well, there's a group here, there's another group here, and there's another group here. Okay? So, but it doesn't see that. So the question is, can it find those groups? And here we're going to show an algorithm to help and to allow a computer to possibly find groups within a set of data. So, maybe it will find this, this, and that. Okay? So here's the way it works. So here we have a bunch of data, and the algorithm works by first picking 3 initial cluster centers. Now 3 is what we tell it to do. So the algorithm, at least the basic algorithm, doesn't know to pick 3 or 4 or 5 or 10 or how many groups. So we have to kind of intervene or make an arbitrary decision, because it's going to be arbitrary if we can't see it either. In other words, if it was 1,300 dimensions, of course we can't see that, so we don't know how many groups there are going to be either. So that's a weakness of this theorem, is that we have to decide in advance, before the algorithm even runs, whether it's going to be how many groups or clusters we want to find. Okay, so pick 3 initial cluster centers randomly. So first of all, we say 3, and then the algorithm will just arbitrarily choose in this space 3 random points to be the centers, the so-called centers of the cluster. So maybe there'll be a dot here and a dot here and a dot here. So any 3 random places it will choose as the initial cluster centers. That's hopefully not going to be the end result. I mean, it's unlikely that it's going to get, the clusters might be, this might be a group, this might be a group, and this might be a group. So the cluster center for this one might be somewhere around here and here and here. But I'll talk about that a little bit more. But anyway, so let's see this. So, so here, it just arbitrarily 3 so-called cluster centers. Okay, next, assign each point to the closest cluster center. So it has to check, how far is this point from here? How far is this point from here? This should be green, I think. I don't know why it's showing up as gray. That should be green. I'm not sure why it's gray. This should be, so how far is this point from here? How far is this point from here? How far is this point from here? And if it's closest to here, then we're going to say that this point belongs to this cluster. And we do the same thing with all of these. How far is this point from here, here, and here? If it's closest to here, then it's going to be part of this cluster. So we assign each data point to one of the clusters defined by the so-called cluster center, although it's not really the center at this point. Okay, next, we move each cluster center to the mean of each cluster center. So this was the original one, but now, this is actually the mean of these red squares, or red diamonds. What do I mean by that? Well, if you take each one of these points has an x-coordinate, right? This has an x-coordinate, this has an x-coordinate, this, right? They all have x-coordinates. Here's the x-coordinate for this one, here's the x-coordinate for this one, here's the x-coordinate for this one. So they all have x-coordinates. It means those x-coordinates are all numbers, right? So you can just take the mean of those numbers. How many points? 1, 2, 3, 4, 5, 6, 7. You can just take the mean of those 7 numbers. You're going to get a number. And that's going to be, so you're going to get a number, and it's going to be about here. And then you can take the y-coordinates of all these points, and you're also going to get a list of 7 numbers. You can take the mean of those 7 numbers, and that's going to be the y average. That might be about here. And so if the x average is here, and the y average is here, then we'll say the center is here. So that's what we mean by the center. Okay? And the same thing with the green ones. So the green center might be here, and this color center might be there. Okay. So we move the centers there. Now what do we do next? Well, now that I moved this center from here to here, maybe, what? Or I should say, now that I moved this from here to here, maybe this green one is no longer closer to here. It might be closer to here, in which case we should make it red. In other words, say it's part of the red group. And maybe there are other points that also move from one group to another. So that's what we do next, is we recalculate the group memberships. Whoops. So move each cluster center to the mean of each cluster, and then reassign points closest to a different new cluster center. So like I said, this one might go to here, might be part of this group now, and maybe some other ones. This one might be part of this group now. So we have to reassign the points to the new groups. Maybe not all of the points will move, but maybe one or some of them will. So the ones that are going to move are the 3 ones with animation. So this one, you can see it's animated. This one moves, I guess, to here. No, moved to here. This used to be green. And, I don't know, this one also did. Okay, so now what do we do? Well, now we have a different set of points, so this is probably no longer the center. So what do? We recalculate the center again. So, and same thing, this is probably no longer the center, this is probably no longer the center. So we move these to the new centers, and then what do? We recalculate the membership again. And we just keep doing this repeatedly, and obviously the computer can do this very quickly. Recompute the cluster means. So this one goes here, this one goes here, this one goes there. Move the cluster centers to the cluster means. And keep doing that. And then when do you stop? You stop when no more of the points move to new clusters. So then, if none of the points move to new clusters, then there's no point in recalculating the cluster center again, because it won't change. And so then there's no point in checking whether points move to different clusters, because nothing has changed. So you just keep doing it until nothing changes. Okay, and now we say this is one group, this is another group, and this is another group. Okay, and this is called Kmeans, where K stands for the number of clusters you're going to do. So we just did 3, so we might call it 3 means, although I don't think people usually call it that, but that's what the K stands for. Okay, and this is called K-means clustering. This is one algorithm to find means, and we saw the weaknesses of this are that you have to decide what K should be, and also the points at the beginning and the centers are just randomly assigned. We just put 3 points in the space randomly, and that's obviously a weakness. and it means that if we chose a different 3 points, we might have gotten a different answer for the group. So it's not perfect, but this is how it works. Okay, so you have disadvantages and so on. Okay, now instead of doing the means, you could do the medians, right? Because calculating the mean of a set of numbers is one thing, but you can also calculate the median of a set of numbers. And remember, we were calculating the mean of the x values and the mean of the y values to get the location of the center, but we could have instead calculated the median of the x values and the median of the y values to get it would have been a different center. And actually, in our code here, we're going to be doing using a k-means that depends on the median instead of the mean. And there's just some reasons why you might want to do that. Anyway, the idea is that basically the same thing. Just use a mean or the median. The median is kind of less sensitive to outliers. But anyway, we won't worry about that. Okay, that's what k-means is about, and we're going to need that in our code.